Hey guys, my name is Abhishek and welcome to the video demonstration of a multi-tenant SaaS application uml.io. This is a utility which helps you to obtain a UML class diagram from your set of Java class files. All you have to do is upload a zip containing all your Java files, and the server takes care of parsing the Java files and giving you a UML class diagram. In this portal, I have integrated the services from 4 independent tenants, each of which has the capability to parse the Java files and give you a class diagram. These tenants are reflected on the left hand side of the browser. Before getting into how these tenants are organized onto the cloud infrastructure, let's take a quick look through the UI, how the workflow is and what results you obtain and how to navigate through it. Choosing the very first tenant, Suchishri, let's begin by uploading a zip file containing all the Java class files. You just need to click the browse button, choose a zip file. So I choose the very first zip file, that is achieve.zip. I open it and I say upload. When I upload it, the request goes to the server from the client containing the zip file, which is then passed onto the server. The server parses it and gives you a PNG image which contains the class files. On the right hand side of the portal, you have a section to grade the submission. Let's grade it by giving a grade and giving some comments and submitting it. These comments are saved into a database. Moving on to the next tenant, it has the similar UI, however on the back end it uses a different utility. So this time we upload some other zip file. I open it, I again upload it, it processes the zip and gives you the UML class diagram for it. Similarly, you can grade the submission, but here you can grade it on a pointer basis, unlike the previous one where you have to give the grades being A plus, A minus, B and so on. You can comment on the output that is generated and persist the data onto a database. The database which is being used to back all this information is MySQL. Moving on to the third tenant, again the steps remains the same. So here you see you get a different class diagram this time. This is because this tenant has used some different utility to generate the class diagram from the zip file that was uploaded. Again, the status here can be either complete or non-complete, and the comments which you can give here is say A plus work and so on, and submitted. The data has successfully been entered. Moving on to the last tenant, again the procedure remains the same. You choose a zip file, upload it, it goes to the server gives you the result, and then you can also grade the submission here. Now one thing to observe is that each of the tenant has a different grading criteria. While tenant 1 and tenant 4 has a grade based grading criteria, tenant 2, that is Bhakti, had a pointer based grading criteria. On the other hand, Huzefa has just a binary status of whether the output that was generated was complete or not. One thing to observe here is each of these tenants has one particular field in common, that is the comment section. So for such a scenario where the data to be stored is different for each of the tenant, we use a technique of storing data in the database called as the extension table approach. In the extension table approach, the data is organized in a form something similar to this. So you have a tenant table which holds the information about the tenant. In our case, the tenants being Suchishri, Bhakti, Huzefa and Umang. Each of them has a tenant ID, a tenant name and a tenant description. For each of the tenant, there can be multiple records each time we use their utility. So this data persists into a table known as tenant data table. The tenant data table has a tenant ID which is a foreign key to the primary key in tenant table. So every time you do a submission, records are entered into the tenant data table and the tenant ID is used to link it to the tenant corresponding to which the data is. Now, as I told you in the previous couple of minutes back, that each of the tenant has a common field, that is comment. So the tenant data is used to persist this common field in here. However, there were some other fields as well. These fields are stored into a third table known as tenant extra in the form of key value pair. So for a particular record, you'll have an entry into tenant data table, and at the same time you'll have an entry into the tenant extra table. You have a key, that is the record ID, which is used to link the data in the two table, and all the other data except for the comment is stored in the form of key value pair as shown here. That was all about how the database looks like. Let's move on to the cloud infrastructure and understand how these tenants are hosted onto the EC2 console. So on the EC2, as you can see, I am on the EC2 dashboard and into the instance tab. In the instance tab, I have 5 instances running. Each of these instance denotes what these instances actually are. The very first is a tenant, that is Suchi. So this EC2 instance hosts the service which parses the UML created on the portal at the very first tab. So the result you obtain on the screen is taken care of by the very first tenant. Similarly, you have tenant Bhakti, tenant Huzefa and tenant Umang for the second, third and fourth tab respectively. Apart from these tenants, I have a portal, that is the UI, which you see here. This UI is also hosted onto a different EC2 machine. Let's take a look at the availability zone where these EC2 machines are running. So of the 5 machines, 3 are running into the availability zone 2A and the other being at 2B. The services running on these instances are made available to the external world on a particular port. These ports could be listed here and the service is available at 9090. If you take a look at the portal also allows you to connect using the port 9090. Now, if you have observed that in the URL, the starting URL and the port remains same from all the tenants. How is this managed? This is managed with the help of application gateway, which is present under the load balancer utility. So under the load balancer utility, as you can see, we have multiple entries. Of this, one of them, that is this particular entry in here, is basically a load balancer as an application gateway. Let's take a look at how this is configured. So the structure of this load balancer is such that for a load balancer you have multiple target groups. Let's get into the target groups. So as you can see, these are the 4 target groups. Each of these target group has some machines or EC2 machines placed in it. The very first target group is for Suchi, and Suchi's EC2 instance machine is placed in this target group. As you can see, it has a healthy status and is up, running in availability zone west 2A, and its port 9090 is exposed. Similarly for the other target groups. So for Bhakti, you again have the instance which was running on 2A, port 9090 being exposed to the external world. Similarly goes on for Huzefa as well and Umang. So the tenants are hosted onto individual target groups. Now the task of routing the request is taken care by the application load balancer. So this is the application load balancer. The policies of routing are listed down here. It says that when a request arrives at a port 9090 with default action, that is no action, it should be routed to Suchi. However, if the request that comes has a path Bhakti or something which has a prefix Bhakti, should be directed to tenant 2 Bhakti. Similarly for Huzefa and for Umang. So this is an example of a path-based routing algorithm that is being implemented using a load balancer. Okay. Now, there can be a situation that a particular instance can be overloaded due to excessive traffic. In order to handle that, we have created 4 classic load balancers. The main purpose of these load balancers is to take care of traffic on a particular instance, so that if the traffic on a particular instance goes beyond a certain limit, the auto-scaling group which we have created multiplies the instances and the distribution of load is taken care of by the load balancer. All these infrastructure is basically orchestrated in the Oregon zone of the Amazon availability region. Similarly, the RDS service of Amazon is also being used. As you can see, the RDS service that is being used is MySQL. So that was just an overview of how things are in uml.io, how tenants are organized, how the data is stored into the database, and how different grading criteria, how different data from different tenant can be organized into a single database using something what is called as extension table policy. So yeah, that was pretty much about the demonstration. Hope you enjoyed. Thank you.